All right, you guys, if you don't have access to Desmos, here is challenge one, the roller coaster. So what I'm going to do is I'm going to set it up on Desmos for you, so you can answer the questions. If you don't have access to Desmos, you can just watch this video. All right, so roller coaster, aka using factored form to predict the equation of a polynomial graph. And if you can't print this out, then you should be writing down the questions on separate paper and giving me pictures of that paper to submit. All right, so the Math America Land Carnival Company has decided to build a new roller coaster to use at this year's county fair. The new coaster will have a very special feature. Part of the ride will be underground. The designers will use polynomial functions to describe different pieces of the track. Part A of the design is shown at the right. All right, so you can see part A right over here. To help get an idea of what to try, start by checking the graphs of the equations below on Desmos. So I'm going to do that for you guys. Think about how the equations and the graphs are connected by responding to the questions below. Now, you should actually already know some of these answers because you did the notes. So use those notes to help you as well. All right, so here is the first equation. Boom, boom. Okay, I'm going to minimize this a little bit, and I'm going to maximize that. Here's the second equation, and here's the third equation. All right, so the first question asks, what two factors do equation 1 and equation 2 have in common? You don't need Desmos to do that, okay? So you should be able to look at those equations and answer that question. Now, part B says, how do we see these factors reflected in the graph of each equation? So now I'm just going to have us look at equation 1. So think about these factors that were in equation 1 that you just found. How do we see those factors reflected in the graph? And I'm just going to give you some points here. How do we see the factors of equation 1 reflected in this graph of equation 1? So you should answer that question. All right? Then it asks, what is the degree of equation number 1? All right, so you should be looking at that, and your notes told you about how to find the degree. So what is the degree of equation 1? And what is the degree of equation 2? It even gives you a hint. Convert, or you might want to convert them to standard form to be able to see the degree. You can see it in factored form, but maybe you want to convert it to standard form, okay? Part B. Number 2, part B. How do you see the degrees reflected in the graph of this equation? So let's think about this. Think about the degree of equation 1 and look at equation 1. What do you notice? Now let's go to equation 2. Here's equation 2. Think about what was the degree of equation 2. And look at equation 2. What do you notice? Okay, so you got to put that in words and do that there, okay? So going back, no equation 1, no equation 2. Let's minimize this. All right, let's move on to this next question. Now, what is unique about equation 3? So now let's look at equation 3. How is this equation different? Or there's something specific that's different about this equation in comparison to equation 2 and in comparison to equation 1. What's different about equation 3 in comparison to the other two equations? Right? What's unique about the equation And what is unique about the graph? So that should be 3-part A and B. All right. So you should have been able to answer all of those questions just from the notes and what I've shown you here on Desmos. All right. Thanks.